One of the most successful theories in our understanding of the universe is the Standard Model of particle physics. This model is basically like a periodic table, but for fundamental particles, as it provides details on the particle and its properties, such as spin, charge, and mass. But wait, what's a fundamental particle? So, basically, a fundamental particle is a particle that cannot be split up into any further pieces. For example, an atom, as we know, can be split up into a proton, and a proton can be split up into quarks. But quarks, they cannot be split up any further. So, they would be found on the Standard Model, which they are. The model consists of 17 particles. These particles are split into sections, fermions and bosons. Under fermions, we have quarks and leptons. Quarks are fundamental constituents of matter, and have 6 types, or flavors. Up and down, which in specific combinations make up protons and neutrons. Charm and strange, and then the top and bottom quarks, which are the heaviest quarks. Each quark is heavier to the left of them. Leptons also consist of 6 types of particles. The electron, muon, and tau. Right above them is the electron neutrino, muon neutrino, and tau neutrino. The electron, muon, and tau are essentially the same, but their masses are different. Just wait a second, what's a neutrino? Well, it is a fundamental particle that is nearly massless, has no charge, and has very little interaction with matter. In fact, trillions of them pass through us every day, without us realizing it. This is why they're sometimes referred to as ghost particles. Neutrinos are one of the most abundant particles in the universe. Now bosons, the force-carrying particles. Bosons are categorized into 2 sections, the gauge bosons, where there are 4 of, and scalar bosons, of which there's only 1. First up is the gluon, and it holds quarks together in protons and neutrons. Then there are the W and Z bosons, which are responsible for nuclear decay, and they are very important, because they play a big part in fusion in the sun. And as you may know by now, we can't really live without the sun, so... Next up we have the photon. It is responsible for electromagnetism and light, because as you may recall, light is made up of electromagnetic waves. The last boson is a scalar boson, called the Higgs boson, and it plays a big role in how our universe functions. The Higgs boson gives all fundamental particles its mass. The Higgs actually mediates a field, the Higgs field, and particles that interact with this field have mass. More interaction means more mass, and less interaction means less mass. The Higgs was very recently discovered, only in 2012, at the particle accelerator called the Large Hadron Collider in Switzerland. The Standard Model has been changing ever since it was first conceived in the 60s, with new particles being rapidly theorized, and closer to being discovered. The Standard Model is one of the best theories we have in physics right now, and it is becoming apparent that it will lead us to discovering the true nature of reality.